Okay. Okay, 72 similar polygons. Okay, when we talk about similar polygons, first I'd like to review what congruent polygons were. There were two polygons that were the same what? Shape and same what? Size. What was our sign for congruent? An equal sign with squiggly on the top. In a polygon, what determines its shape? You don't need to write this down because I want you to write something else underneath it. I'll draw a triangle here. And then I'll try to draw the same shape triangle, just a little bigger. Now, I did okay, probably not great. But everybody look up here. Tell me, I tried to keep it the same shape, just different size. What determined the size and what determined the shape? First of all, what is it made up of? A polygon is made up of what? What are these things called?
Angles.
So these are called sides, right?
Oh, I thought you meant things.
The corners are in essence called what? Angles. Okay? So what stayed the same?
Angles.
What? When I drew that bigger, what did I have to do to make it bigger? I increased the size. So shape is determined by the what? What kept the shape the same? By keeping the what? By keeping the angles. Then you guys just tell me that to change the size, I may change the size of the sides, correct? So what determines the size in a polygon? The sides. Okay?
I thought.
Right?
Small triangles instead of angles on the big
If they're the same shape.
Oh, okay.
Okay? If they're exactly the same shape. And we'll see that when we talk about what we're going to talk about today, which is called, instead of congruent polygons, we are going to talk about similar polygons. Those are polygons that are the same shape, and I'm going to say proportional size. Don't worry as much about proportional, but I didn't say same, right? I just said proportional. Or proportional size. I'm sorry, change that to proportional size. I want to use the same verbiage. Well, the same shape, what do you think that means? Congruent what?
Angles.
Angles. So the angles stay the same, don't they? For right now, we'll just say different what? What determines the size? The sides. That's what similar polygons are. also gonna talk about what's called a scale factor. How many of you ever heard the term something is to scale? Never have?
I think I might be
Let's
wrong.
say, like when you, how many, you ever did models when you were younger, you still do them now? That used to be a really, when you didn't have cell phones and you didn't have all these games to do, my dad just told me he used to do these really intricate models with the glue and paint and everything. It was pretty cool what they made. They had to do something, play with something, right? But they would say, it's a 1/24th, it's to scale, but it's 1/24th or something like that. That would mean that if something was a foot on that model, the small model, it would be how big in the real world? 24 feet, right? So everything is to scale. It's just shrunk down. Another example of scale factor and basically similar things is my wife said she used to love these when she was a kid. Things called shrink-a-dinks. I don't know if you guys have ever heard of them. They probably have something like it now. But what you did is you had a little, I don't know what they made the fabric of, but you had this picture of a pony. And you'd color it in like a coloring book using markers and stuff. Then you'd go put it in the oven and they would shrink down and would pull those colors together too and make the colors more vibrant because it was kind of like pixels when you shrink it down. And it was a really neat deal. So what happened, in essence, the moral of the story is they became the same shape, but they just what? It looked the same, it was just what? Shrunk at a certain scale. Okay, the scale factor is, for instance, if I said this triangle, and I'll draw a triangle. How about this? I'll try to draw two similar triangles again. See if I can do a better job with it this time. Well, I have drawn the second one, so how do you know it's worse?
Well, you have to mess up on the second one too.
It's not too bad. Yeah, it's not too good either.
Left side's a little long.
It's not too bad, isn't it?
See, it's a little.
Okay, we'll call this A, B, C. Call this triangle X, Y, Z. What if I said your scale factor was 1, 2, 3? And I told you that the length of this side was 4, this one was 3, and this one was 5. What would the sides of the other triangle be?
3.
What am I saying when I say a scale factor of 1 to 3?
12, 9, 15.
In layman's terms, how would you say that to me? Coach, that thing is what? 3 times bigger than the other one, right? So, this would be 4, what would this be? This one was 3, what would this one be? If this one was 5, what would this one be? That's a scale factor of 3 1. Now, whether it really looks like it, obviously it doesn't matter. How do we find that scale factor? Well, scale factor can either be from smaller to bigger or what? Bigger to smaller. This time, when I say 1 to 3, I talked about it from what? Smaller to what? So let's look at the sides. Let's look at the ratio of the, I'm going to say corresponding sides. Can you guys tell me what you get when you do that? Well, what one corresponds to this one? 4 over what?
12.
What does that reduce to?
3 over 1. Or 1 over 3.
1/3.
I was getting there.
Let's do another set of sides. Which one do you want to do next?
5/15.
5 over 15. When I reduce that, what do I get?
1 over 3.
I see a pattern here. It's just
What about the next one? 3 over.
18.
So what do you think my scale factor here is? Important things to relate to here. Because of this, the corresponding sides are said to be, you know what this word I'm going to use is? Anybody know?
Proportional.
Which thus to what? What I was talking about of having what? Proportional sides. So for any two similar figures, polygons, you're going to have what? It's going to have the same shape. It's going to have congruent what? Angles and what? Proportional. So when you take the ratio of those corresponding sides, you're always going to get the same what? What word?
Scale factor.
Just like you did right here. Let's all get that written down. And if you'll look on page 469, you see a similar figures deal there, where they talk about the ratio of the corresponding sides all being the same, and how the angles, corresponding angles, are congruent. Which angles will be congruent here? Let's go ahead and label that up here too. Which angle is congruent to angle A here?
Angle S.
Which one is congruent to angle B?
Angle Y.
Which one is congruent to angle C?
Angle Z.
You think they're always going to face them the same direction and make it easy for you?
No.
Probably not. So you think you get an idea of what it means to be proportional? What we mean by proportional sides?
C.
It means if we just put the ones that correspond over each other, that fraction will always reduce to the same, right?
Yeah.
So guess what we're going to make? What did we learn yesterday? About what? What was yesterday about? Proportions. Proportions and ratios, right? Proportions is when I had like A over B is equal to what?
C over D.
You think we could make proportions here? I mean, let's say I gave you all this information, I didn't give you that one. Couldn't I say 4 over 12 should equal what? 3 over x?
C.
Cross multiply and solve and find x? I bet we're going to do some of that. That'd be fun.
I don't get how congruent polygons, even if it's the same shape. By same shape, you mean like a triangle and a triangle, right?
Yeah.
Okay, so
Yeah.
how is a triangle that's this big congruent to a triangle that's
I didn't
this
say
big?
congruent. I
Or not
said similar.
congruent. So
Similar.
you said the shapes or the
Right,
angles.
congruent polygons have the same shape and same what?
Angles.
So they have the same angles and
So
same
they're both going to be like
sides.
this,
They're
just-
going to look exactly the same.
Okay. then
However, similar will look like they're shaped the exact same way, but will have different what? Size,
okay,
proportional. So you
okay.
see what I mean? It's a shrink. It's like going to the copy machine, drawing a picture, and pressing 50%. It makes it half as big, doesn't it?
Yes.
But it should still look exactly the same, right? It's just shrunk. You're either shrinking or making things bigger by a scale factor of 1 to 3, 2 to 3, 4 to 5, whatever it may be.
Okie
Okay.
dokie.
Has everybody got this written down?
C.
Can I erase it and then we do some ones from that workbook?
C. C1.
Does everybody get those red workbooks out?
You look like this. It's a geometry on the front. It's all red. You know. Page 85.
Yeah, we can do that, son.
Alright. Okay.
I mean, why not? Right? What page you say? 85. Yeah, some good ones on there. Let's look at let's look at number 1. First of all, they want us to say if these two are similar. Then they want the scale factor, and you write a congruency statement. Well, first things first. I better see what corresponds to what. Here's one thing to do. This one is congruent to what? The other one that's 59, right? 35 is congruent to 35. This one's congruent to this one. And what I advise here, guys, is sometimes it's hard to see what corresponds to what, but luckily this one is in the 6 corresponds to the what? Because it's 1 mark to 3 marks. Okay. What does that reduce to? 2 goes into that 3, 2 goes into that what? So that's the scale factor here. To determine whether these two are similar, I need to see if I get the same scale factor for what? For all 3 sets of sides. So, okay, that's what I started with. So that's why I'd gone in and find it, because if you ever find the scale factor is different, you're done. They're not similar, are they? Okay, so I did 6 over 4, and which one do you guys want to do next? 9 over 6. Well, what's the common factor here? 3 goes into that 3 times, 3 goes into that what? Okay, so we're the same. Now, unfortunately, they do throw some decimals at you here. What's this? 10.5 over what? 7. Here's what I would do. If you put that into your calculator, what would you get as a decimal? 3 over 2. Wouldn't you get 1.5? You guys agree?
Moving my calculator up.
So now what I want you to do is go 10.5 divided by 7 and see what you get. See if you get what? 1.5. What is it?
1.5.
Sure thing.
So is our scale factor the same? So yes, they are similar. Your scale factor is equal to what? This I want as a fraction, 3 over 2. Unless they give you all decimals, then you can make it decimal. Now, next thing they talk about is what is called a similarity statement. You guys remember congruency statements, where you're supposed to write it in corresponding order, correct? We need to do the same thing here. So triangle ABC. Now, what am I going to use as a sign for similar? Well, what we do is it's not quite congruent, so we use this little, just the top of the congruency sign. That means similar. Triangle, well, if I did ABC, what order does the other one need to be in? D, E, F. Agreed? So now I've done the 2 things they asked me to do if they were similar. Questions on that? It's not too terrible, is it?
We have to write scale factor equals 3 over 2, and the similarity statement is.
No.
We just write 3 over
SF
2.
equals 3 over 2. How about that? And you don't have to write similarity statement at all. I'm just defining it because we hadn't talked about it in the notes yet. Kind of combining talking about it and doing an example at the same time. Clever, huh? That way we save a little time, give you a little more time in class. If you look at number 2, is everybody okay with that? Can I move on? Number 2, and by the way, it asks you to justify your answer here. How did I justify my answer? By showing that 6 over 4 was what? And by showing that 9 over 6 was what?
3 over 2.
And that 10.5 over 7 is what?
1.5.
I justified my answer. If you don't justify your answer, you didn't do the problem. Got it? So show all steps and work. This one here. What am I going to get as a ratio of corresponding sides every single time? 7.5 over 3 or 7.5 or 3 over 7.5. They all of them are a decimal, so I'm okay. What would that be as a decimal? 2 point what? Huh? So what's your scale factor here on all of these? So your scale factor is 2.5.
We have to write that 4 times.
How long did it take me? Possibly 5 seconds, right?
Possibly less.
Okay, you're haggling over 5 seconds. Prove to me you know what in the world you're doing. Now, or I can start counting right or wrong and making you show your work. Now, I need a similarity statement. So let's put these in corresponding order. How am I going to figure out the corresponding order here? Well, look at the angles. You need to start at a 1 mark. So I would go QRSP is similar to, I start at Q, what do I start out here? XY, ZW. There's your similarity statement. Think you guys can do that?
Yes. But my calculator is being stupid again. Like I put in 7.5, and I put in the fraction sign and it won't work.
No, don't use that. Use divided by. When you use the fraction sign, won't work with decimals. So that's why I was saying when they give you all decimals like that, it's okay to leave your scale factor as a decimal, because they didn't give you an option, did they?
No.
I got it now.
Okay. Now, each pair of plot, find the value of x. Oh, this is those problems I was talking about, right? Now, they give you more information than you need here. You know why? Because all you got to do is find the scale factor, don't you?
Yeah. 7.
And this is what you'll find when you're doing this. First of all, I need to involve this x in my proportion, don't I? What corresponds to the x? It's hard to tell, isn't it? Here's how you can do this. See these marks on here? How many marks do they have on this angle? 4 to what? 3. How many marks do they have on this angle? 4 to what? So the x is 4 mark to what? 3 mark. So go over here. Which one's the 4 mark to 3 mark?
D and C.
Okay, so I could say 13 over what? X is equal to, now I need to have 2 more corresponding. You got to make sure they're corresponding. Which one do you guys want to use?
12 over 6.
Okay, she said 12 over 6. Do they correspond? 1 to 2, 1 to 2. Yes, that'll work. What else could you have put there? 14 over 7 or what? 26 over 13. You'd get the same answer either way. This is a pretty easy equation to solve, isn't it? What would I get? What's 13 times 6? Huh? 78 is equal to, what is x times 12?
X divided by 12.
X times 12.
Oh, 12x.
12x. What is my next step?
Divided
Both sides by?
12, which is equal to
Well, 6? Or no? It's not right.
It's right because.
Let's see. So we do a fraction that'd be, what is 78 over 12 reduced to? So 13 over,
Not 6.5.
huh?
Yes, it is, because 7 times 2 is 14, 13 times 2 is 26, 12 times, or 6 times 2 is 12, 13 times...
Well, let's reduce it. That'd be 6. If you just want to cut it in half, that's what? 39. 3 goes into that 13. 3 goes into that, what? Twice. So 13 over what? Which is 6.5. That's your answer.
Because, 35 by 2.
I just kept dividing by 2 and kept reducing it down.
Wait, is the number 6.5?
X is 6.5.
The answer is,
Sorry. So
I'm going to say 13 over 2.
Okay, so you can say 13 over 2.
Absolutely.
Saying 6.
That's the better answer, actually.
Okay.
Why is that a better answer?
Because to do any kind of, say you wanted to plug it back in and see what something was, most of the time when you get into higher level math, 6 and 1/2 is a mixed number. You're going to have to change the 13 over 2 to put in any equation anyway. So why mess with it? Now, if I ask you how long something was, or how far away I am from you, 6.5 means more to you than 13 over 2, correct? But you're going to find when you get into higher level math, they're going to want everything, if you don't start with a decimal, don't end with 1. So if for some reason, a lot of times when you, listen to me, a lot of times when you find X, you have to plug it back into something else, don't you? Agreed?
Yeah.
Can you multiply 6.5 times 6.5 as a mixed number? No, you have to change it into an improper fraction to multiply them by hand at least. Yes, you can put 6 and 1 over 2 into your calculator times 6 and 1 over 2. I realize that. And I know you realize you can put 6.5.
Yeah.
But what did I just tell you? If you don't start with a decimal, don't what?
And with the decimal.
So listen to me. You're not listening, you're trying to justify your argument. There's a difference. I'm telling you that a lot of times you have to plug this back in, and they're going to want that answer as a what? Fraction. Okay? So is 25 over 7 going to be nearly, if you had an answer of 25 over 7, that's a little bit harder fraction than 6 and 1/2, isn't it? 13 over 2. It is more handy in higher level math to leave that as an improper fraction than it is to make it into a mixed number. Because to add with it, to do anything with it, you've got to change it back to an improper fraction anyway. So you're wasting a step. The only time it's handy is when I'm knowing I'm counting or trying to get a better feel of the value of that number, which sometimes is handy. But I've been doing this a little bit longer than you. Leave it as 13 over 2.
Jeez,
It's
come
not
on.
a big one.
Now, so how should you leave your answers, guys? Improper fractions. Now, what am I going to do here? Another thing you can do, you're going to have to figure out what corresponds to what, right? You can make little squiggly marks. I do this sometimes. I'm not going to make congruency marks because that would be inaccurate because they're not congruent, but I make a little squiggly mark. Doesn't this correspond to this? Would everyone agree? So that's why I made that mark and that mark. What does this correspond to? That one? I've in turn marked what my equation is going to be, which is 3 over what?
1.
Why would it be 1? I'm talking about the corresponding sides. 3 over 9 would equal what corresponds, I would need, what would I need on top? If I have the 3 on top, what needs to be on top? 4 over x plus 5. I now have a proportion that I can solve. Everything up here times everything down here, so it's going to be 3 times the x and 3 times the 5. So 3x plus 15 is equal to what is 9 times 4? 36. Subtract 15 from both sides. What do I get? 3x is equal to what? 21. Divide both sides by 3. What is x equal to? Your assignment is numbers 1 through 24. Write problems, draw figures, show all steps and work. I need to see all these steps. I need to see your proportions. I need to see you work them out. Prove to me you know what you're doing.